Confidence and significance levels. So what are confidence levels? Well, the confidence level is the frequency of possible confidence intervals that contain the true value of their corresponding parameter. A confidence interval is a type of interval estimate that's computed from the observed data, and the confidence intervals for a normal distribution is evaluated for continuous variables like sales in dollars, income of customers, age of customers, score in mathematics, etc. Well, what we're trying to say is that the assumption is the majority of individuals fall under a normal bell curve. Well, everyone falls under the bell curve. But we have a lower and upper limit on that bell curve, and that's alpha. And so you see the 0.025 on each side. Because it's on each side, this shows that we technically have a two-tailed test, which means alpha is the aggregate of those two, so 0.05. And what that generally means is that 95% of the population will fall under this main bell curve, but 5% of the population would fall below or above that. So let's say for IQ, the standard bell curve would put the majority of individuals between about 100 and 120 IQ. So anything below that and anything above that is outside of the quote-unquote norm. So that gets into the critical region. The sampling distribution of a statistic has two regions. We have a rejection region, or critical region, and our non-critical region, or region of acceptance. What we're trying to do with hypothesis testing is saying that something is outside of the non-critical region. It's in that critical region. So when we hit the critical region, we can reject the null hypothesis corresponding to this test statistic in this sample. When it comes to decision making, the critical region will help in this process by defining the region of acceptance and region of rejection. Now that decision can be correct or incorrect. So if a sample test statistically falls in the rejection region, then we reject the null hypothesis. So in the decision-making process or approach to hypothesis testing, it's crucial to decide the level of significance prior to the collection of the sample data. And that's that alpha number I was telling you about. So generally, you'll see that set as 0.1, 0.05, or 0.01. This level of significance refers to the probability of a type 1 error alpha. So if we're trying to reduce false positives, we may want to set a lower critical region, like 1% instead of 5%, as in 0.01 versus 0.05. So for example, if alpha is set to 0.05 and you reject the null, then there's a 5% probability that you've rejected the null when it's true. So essentially rejecting due to chance instead of statistical significance. The desired level of significance depends on the amount of risk you want to take in rejecting the null when it's actually true. And we also have this confidence coefficient. So it's the complement of probability of type 1 error, 1 minus alpha, which is type 2 error or beta. And that yields the confidence level multiplied by 100%. It represents the probability of concluding that a specific value of the parameter being tested under the null is possible when in fact it's true. And this in itself is a measure of the accuracy and repeatability of a statistical test. So, the risk with beta. This is the probability of committing a type 2 error, and it depends on the difference between the hypothesized and actual values of that population parameter compared to that sample. Now, beta is always computed as 1 minus alpha, so it's inversely proportionate to alpha. Remember that alpha and beta essentially equal up to 1. They're both decimals. So usually you're seeing 0.05 alpha and 0.95 beta, sometimes 0.1 alpha and 0.9 beta, and for stringent testing, 0.01 alpha and 0.99 beta. So the beta risk depends on the magnitude of the difference between the sample mean and can be accelerated, exacerbated, managed by increasing the test sample size. Now the value 1 minus beta is known as the power of a statistical test. It's a component of the probability of a type 2 error and refers to the probability of rejecting a null when it's false. So what factors affect the power of test? So if you've ever heard of a power analysis, well, the population standard deviation is inversely proportional to it. The size of the sample we use, 30 versus 300 people, we're much more likely to get an accurate reflection of the population with 300 people versus 30. So it's directly proportional. And that alpha, that level of significance, is also directly proportional.